So I thought that the best way maybe to go over um, 4.3 part one with you would be to just do a few of the sample problems of the variety that you're going to have to do. And the first thing that you need to know is that we're talking about the six trigonomic functions, which are sine of theta, cosine of theta, tangent of theta, and then we've got their inverse functions, which is cosecant of theta, secant, it's an E, secant of theta, and cotangent of theta. And you might have heard in geometry, if you take yourself way back, you might have heard the expression SOHCAHTOA, and it was spelled SOHCAHTOA. And I always think of it as some old hippie caught another hippie tripping on acid. But what it really does is it tells us our sine, cosine, and tangent and how they work out together. And it's saying sine, some old hippie, is opposite over hypotenuse. Cosine, caught another hippie, is adjacent over hypotenuse. And then tangent, our TOA, is opposite over adjacent. And what that really refers to is when we have, say, a triangle, a right triangle. Ooh, well, that straightened itself out for me. If we have an angle theta, right, and say, we'll call this 2, this 3, this 4. I'm just making things up for this, right? What we're saying is that from theta, this right here would be our opposite. It is the side opposite the angle. So in this case, our opposite would equal 2. Our adjacent is the non-hypotenuse that is connected to that angle. So our adjacent in this case would be 3. And clearly our hypotenuse is the longest, right? And that is going to be 4. And so what we're saying is sine of theta equals our opposite, which is 2, over our hypotenuse, which is 4. So it would be 2/4. And when we reduce that fraction, we're looking at 1/2, right? Same thing here. We are talking about cosine now, which is the adjacent, which is 3, over the hypotenuse, which is 4, and that's an irreducible. So that is our exact value for cosine at theta. Tangent is opposite over adjacent. We also think of it regularly as sine over cosine, but when we have all the numbers on a triangle like this, it's easier to just go it's opposite over adjacent, which is 2/3. Now, cosecant, I wrote cosecant, secant, and cotangent in this order specifically because cosecant is the inverse of sine. It's like saying 1 over whatever sine is. But ultimately, when we do the math on that, it would just be the reciprocal of whatever we got. So here it would be 2 over 1, which just equals 2. Secant is the inverse of cosine, which means it's going to be 1 over cosine, or 1 over 3/4. And when we go to solve that, it would wind up just being 4/3. So we could think of it as just flipping over the fraction, or we could do up the math on it, right? Cotangent is the inverse of tangent, which is just 3/2. And that's how you're going to find your 6 exact value of your 6 trig functions. When you get to the homework section of it, it's going to give you a triangle, but it is not going to give you all of the information. So if we look at number 5 in that first homework section, you have a triangle, a right triangle. And it's giving you your theta, right? It's saying that this is your theta angle, and it's giving you 2 measurements, 6 right here and 8. But it does not give you the hypotenuse. But remember, we're dealing with right triangles, so we know how to find the hypotenuse of a right triangle given the other 2 sides. If you remember, we used the Pythagorean theorem, which says that if we add the squares of both sides, if we have a squared plus b squared, which are the 2 sides of a triangle, it will give us c squared, which is the square of the hypotenuse. So we know what our 2 sides are. They are 6. So if we square that and add it to 8 squared, it should give us whatever our hypotenuse is squared. Right, so we're looking at 36 plus 64 equals c squared, which is 100, right, is c squared, which means that c, if we took the square root of both sides, would just equal 10. So we know that our hypotenuse is 10. And so now we can find, using that information, all 6 trig functions, because what is it telling us? It's telling us that the opposite equals 6, right? The adjacent equals 8, and our hypotenuse equals 10. And so now, knowing all of those trig functions, knowing our SOHCAHTOA, right, we can go, well, sine is some old hippie. So we know that sine theta equals the opposite over the hypotenuse. Well, that's 6 over 10. And when we reduce that fraction, we know it's 3/5. Then we go, well, cosine caught another hippie, right? Adjacent over hypotenuse. So that's going to be 8 over 10. And when we reduce that fraction, it's 4/5. And then we have tangent, right? Which is tryptophan acid, opposite over adjacent. So we've got 6 over 8. And when we reduce that, we wind up with 3/4. And the other 3 are just inverses, right? So once I know sine, cosine, or tangent, all I have to do is flip them, right? I can go cosecant of theta. Well, that is just the inverse of sine. So I can go, well, that's just 5/3. Secant of theta is the inverse of cosine. So that would just be 5/4. Cotangent theta is the inverse of tangent. So that would be 4/3, right? And that's how you're going to do that first section. When you get to the second section, you're going to have to do it for the 2 triangles that are given. You're going to have to find all 6 for the 2 triangles that are given, and then explain why the function values are the same. So it's simple. You're going to follow that same process, right? And that should get you through 6 through 14. Then you've got that next section, the last section that you have to do for this homework, which is it's giving you a value, and you have to find all of the others, right? And I find the best way to do this, I'm just going to do number 15 for you, because that will set you up for the rest of them. So if we look at number 15, it's saying that you have cosine of theta equals 15, hold on, make sure my eyes are right, 15 over 17, right? So, and then you have to find all of the remaining values for the trig identity. So you have to find sine, tangent, secant, cosecant, and cotangent. But you're only given these two pieces of information, right? Or one piece of information, but it gives you everything you need to figure that out. Because if I drew a triangle, right, a right triangle, and it doesn't matter what I make theta, I'm going to make this theta. Why? Because we have been, right? That's going to be our theta. So we're saying, what do we know about cosine? Well, we know that sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. So if cosine gives us adjacent over the hypotenuse, it's telling us that 15 is our adjacent and 17 is our hypotenuse. And we need to figure out what this other side is to figure what all of the other trig functions would be. So we need to find, I'll call this A, right? We need to find what side A is. But what we know is that A squared plus B squared, well, this is our other side, so we'll call that our B squared, equals C squared, right? So we can solve this problem fairly easily once we figure out what this A, I lost my cursor, there it is, what this A is equal to, right? Once we find out that, we can solve all of our trig functions. So I know that this would be A squared plus 225 equals, I don't remember what 17 squared is. I think it's 289, but I have a calculator on my phone. I'm working from home. I just don't have all of my stuff with me right now. 17 times 17 equals, I was right, 289. So we're going to solve this like anything else. We're going to isolate this A squared by subtracting 225 from both sides. Right? And we're going to get A squared equals 64. Well, that's super convenient because what do I know 64 to be? If I took the square root of both of these, I'd get A equals 8. Right? So now we know, scratch out that question mark because we know that A equals 8. And so we can figure out all 6 of our trig functions now. So we know cosine is 15 over 17. It was given to us. So sine of theta equals opposite over hypotenuse. Well, our opposite is 8, and our hypotenuse is 17. Tangent, we know, equals opposite over adjacent. So we've got 8 over 15. Cosecant is the inverse of sine. You'll want to think that it's the inverse of cosine because they both start with co, but it is not. It is the inverse of sine, which means we are just going to flip over whatever sine is, 17 over 8. Next, we have secant, which is the inverse of cosine. So that's going to be 17 over 15. And last but not least, we have cotangent of theta, which is just the inverse of tangent. So it's going to be 15 over 8. So when you go to do this, remember, look for whatever piece is missing, and then you can fill in all of the blanks on that, right? Then it's just a matter of figuring out the fractions for all 6 of the functions, right? It's giving you one. So if it gave you tangent, right, theta of something, you would know that you have the opposite and the adjacent, and you'd have to find the hypotenuse. If it gave you sine, you knew it was giving you the opposite and the hypotenuse, and you'd have to find the adjacent. And then once you find that missing one using the Pythagorean theorem, you can figure out all of the remaining values for those trigonomic functions. If you need any help, send me a message. I will be happy to get back to you on that. So just let me know. I hope that this video is helpful. I thought it'd be best to just go straight to the homework problems since that's what you got to work on.